This conference will now be recorded.
Okay, so good morning, all, and welcome back to the session. This is Big Data Masters program. Friends, in the previous session, we were going through with the practicals on MapReduce. And from the practical perspective, what we have seen, we have gone through with these particular exercise, what I can say. So we have taken a file, then it is given to splitter, then record radar and mapper. We have written the code for mapper and reducer, and then we were able to execute that particular code. That was working perfectly fine. Now, then we have
Sorry, Ashok, are you sharing something? Your screen is not visible.
oh, let me share. Let
Yeah, please.
me share. I think I thought like I have shared my screen. Sorry for the inconvenience caused. Hmm. And please confirm if it's visible.
Yeah, it's visible now.
Yeah, it's visible.
Perfect. So in the previous session, we have gone through with these particular practicals, and like initially we have write down the code with respect to this particular approach, where we have taken a file, then we have written a code for mapper and reducer, and then we were able to have the execution. We were able to see the outcome. Then we have reduced reducer to 0, and at that moment what we have seen, inside the output we were able to see the mapper files only, or mapper file, as we are having one block, like the file size is very less, and because of that, like we are having only single file inside the output directory. So reducer was not working, what I mean to say, so we have moved with reducer equal to 0, and we have moved with reducer equal to 2 as well. Where like we have increased the number of reducer, and what we have seen over there, like the data is distributed among these particular reducer based upon the system defined function. Okay, what exactly is happening if you are having multiple reducers, say more than one reducer? At that moment, how the records from reducer, from mappers to reducer, like on based upon which function or which logic that those particular records are moving. So over here, a partitioner is working in between mapper and reducer, and it is deciding which key are moving to which reducer. Let me show you over here what we are able to see inside the output directory. This is the output directory, yeah. And inside third execution, what we have seen, we are having two reducer file. It means we have used two reducer. And over here, if I'm going to open this particular file, just have a look, all and two, these are the two records available in this particular reducer file. And if I'm talking about the second file, we are having maximum of the records available over here. So how these particular records are moved to these particular file, that is decided by the partitioner. That is decided by partitioner. Now we have not written any code for partitioner, so it is going to take the system defined logic, and based upon the system logic, it is going to divide these particular records, or what I can say, keys. Okay, key and value. So these particular keys are moved based upon certain system defined functions, and we are able to see two reducer. But can we further optimize it? Can we write down certain logic, so and based upon our logic the reducer will work, and I will be having the records based upon my logic inside these particular reducer file. Or it means, what I'm planning to say these are nothing but machines. Reducer 0 is one machine and reducer 1 is one machine, and this machine is working on less amount of data, and this machine is working on more data. So I'm willing to divide the task. Divide the task based upon the logic, and that logic we are going to see in our next task, that is adding a partitioner class in between mapper and reducer, so that the records which are moving from mapper to reducer, or the keys which are moving from mapper to reducer, those particular keys will be optimized, and each and every reducer will be working almost onto the same data. That is decided by our logic only. Yeah. So the next example is based upon adding the partitioner class. So we are going to add a partitioner class, and this particular partitioner class is going to divide the keys based upon our logic, which we are going to write over here, among the reducers which are available. So just have a look. I'm having this particular class over here. Let me open the shared folder. Over here inside the shared folder, I'm having this particular partitioner class, custom partitioner class. So custom partitioner, let me open this. Okay, and just have a look. So, and let me copy this particular code in order to guide you what exactly is happening over here. Okay, so this is the code which is written over here. Let me try to remove the space and all. These are the things. The logic is very simple. Just try to focus onto the logic. Okay, so I'm going to import certain data types from the Hadoop side. So int writable text, and then I'm going to import the partitioner class MapReduce.partitioner. These are certain settings that we are going to do. Don't focus onto this. Okay, these particular things, these particular settings, I'm going to mention inside the partitioner, inside the main class. Now just have a look. The custom partitioner class extend to partitioner class. This is the system defined partitioner class which I'm going to import, and this is the file name what I have written. Custom partitioner, it is going to inherit the properties of this particular system defined class. And now what I'm having text and int writable. Okay, I'm having text and int writable. So it is going to take text and int writable. And now over here, text is nothing but the key, and int writable is nothing but the value. Okay, and I'm going to define one integer, that is num reduce task. Okay, that is a variable that I have defined. And what is happening over here, like if the key dot to string, if this particular key what I have mentioned over here, and I'm going to convert it to string, because this is in text format. This key is in text format, and text is Hadoop data type. So I'm going to write down the code in Java. So I need to convert it into string. So I have converted key dot to string. It is converted into string format, and then I'm going to check the length. Dot length, and if the length is less than 4, then it is going to return 0, and if the length is greater than not less than 4, then it is going to return 1. So what is happening over here, if like the record length, this is the data what we are having in our test file. This is the data best 32 test. Okay, this is the content of our test file. Now over here, what is the meaning of that particular logic? So if key dot to string length, dot length, if the length of these particular keyword,
Uh,
so say if the
but
length is
Ashok,
Mm-hmm.
This partitioner will work on the output of the mapper, no?
Yes, yes, it will work onto the output of mapper.
And this file is the initial file which on which we are doing this job. This is not the output of the mapper.
This is like based upon text and entry table. What is output from mapper? That is text and entry table only, na? Let me
Yes,
show you.
yes.
Let me show you. Okay, so mapper. Output from mapper is text and entry table.
No, no, yes, that I understand. But
Mm-hmm.
what I am saying that this partitioner code will work on the output of the mapper, like key and one, then next key
Key and
one,
value.
like that. Yes, a
Key
key
and
and
value.
value.
Yes.
Yes,
Mm-hmm.
on that it will work.
So it is not working onto the value basically. It is not working onto the values. It is going to take the key and it is aligning. It is moving this particular these particular record. It is like that. Say uh, one filtration mechanism which is going to filter. Say if the key length is this one. I was showing this. So if this particular, it is going to check these particular values. Say hello length is 5, so it is less than, it is going to
N-
check if it is less than 4. It is not less than 4, it is greater than 4, so it will be moving to 1. 1 is nothing
One.
but the reducer number over here. Reducer 0, reducer 1,
And what
right?
will happen if we have more than two reducer then?
Then you need to like add this particular logic. If else condition you need to add.
Okay,
Okay,
okay, okay, okay.
fine.
Yes, 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 Ashok.
So over here, if the key length is less than 4, then it will be moving to reducer 0. Otherwise, it will be moving to reducer 1. Num reduce task to that will be the output. So simple code, like if we are having two reducer, then how the records will move to which reducer, right? So over here, like what we are going to say, we are going to like move these particular records. Say if big is big, all all of these particular records will be moved to reducer 0, and the records which are having length greater than say 4, those particular records will be moved to reducer 1. Okay, so that is the thing that we are going to do with respect to the custom partitioner class. So
And
let
do
me
we
check.
need to learn this Java coding as well?
No, there is no need to learn Java coding. Just like you just need to go through with the understanding what exactly is happening. We are going to
Okay,
start Hive, and over there, like I will explain. So you just
okay,
need to
okay,
understand the logic. Okay, there is no need to think onto the code like what exactly is happening over here. Okay, just
okay.
understand the logic what I have mentioned. If like the length of the words is less than 4, then it will be moving to reducer 0. Otherwise, it will be moving to reducer 1. There is no need to focus on to these particular things, right? Okay, so let me import that particular class over here inside our code. I'm just going to import that particular class, and it is placed inside the shared folder. It is inside the shared folder. So over here inside the shared folder, I'm having custom partitioner class. Hmm, custom partitioner class. This is, and let me try to import it over here. Okay, perfectly fine now. So just have a look. The custom partitioner class is over here, and this is what we like that I have covered up. So over here I'm having this custom partitioner class, but I need to define this particular custom partitioner class inside the main class, so that the main program will understand that yes, we are having custom partitioner class as well, and it need to act accordingly. So let me try to copy this particular property and paste it over here, and let me remove this. So over here, what we are doing, set partitioner class, and then class name is what, custom partitioner dot class. This is the file name basically. So custom partitioner class inherit the properties of system defined partitioner class. So why I have mentioned this particular name, because my file name is custom partitioner dot java, right? So that is perfectly fine. And let me save this. Over here inside the console, I will be able to see the execution, and let me try to run this. Run configuration, and I need to just mention say fourth execution. Okay, run. Okay, so the execution has been started over here, and we are able to see the logs, and the execution has been done. Okay, so mapper 0, mapper 100% and reducer 100%. So the execution has been done successfully. These are certain counters. We have gone through with these particular counters. Let me show you what is the outcome over here. So fourth execution, this is the outcome. Okay, output directory. And inside the output directory, yes, like we are having files. And just have a look over here. So big is to, these are the words like which are having length less than 4, right? Previously we were having 2 records only. Now we are having 4 records over here. And in this particular file, what we are having the words which are having the length greater than 4. Okay, so greater than or equal to 4. So all dot for big data factory dot for hello, that is having 5 five letters in this particular word. Okay, so based upon that, like what we are able to see, the data or the keys basically, keys has been distributed among the reducer, which was unequally divided in the previous execution. Now like what we are able to see, it is not a fully equal number of keys. It is not having, these particular reducers are not having the equal number of keys, because we are not having say logic in this particular way. So the division or distribution of the keys based upon our logic, whatever we are going to write, and based upon that only the keys will be moved to a particular reducer. So that is the main stuff what we are planning to learn, and we have seen it with the help of code as well, right? All of you,
Yes, sure. Clear.
Yes, Ashok.
any
Ashok,
confusion?
yeah,
No.
Ashok, can you open the output
Yes,
file
yes.
for the any reducer one or reducer two? Can you show?
Okay, okay, let me open. Mhm. Hmm.
Anyone? Okay,
Hmm.
if you see the value big nine, for first one mention nine and the second one mention five. What is this?
Hmm.
Nine and five. What is this? Uh,
That
It's
is
for the
like,
case
that is
sensitive, no?
the,
Case
we are
sensitive.
going
First
through with,
one, big.
yeah, explain, explain Pankaj.
Yeah. It's separate because in first capital B is there, and it is a case sensitive. So that's why for
Okay.
first capital with capital B, 9 times it is repeated, and with small b, it 5 times repeated. That's why.
Uh-huh. Okay, 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 okay. Okay.
Yeah.
Okay, even like you can write down the logic to convert all the letters into the small letters, capital letters or small. You can convert to the small letters, and then you will be able to get like single big over there. Huh? Inside the PySpark, we will be going through with these particular examples. Huh? So this is nothing but we have gone through with the frequency word frequency calculator, and we have calculated the frequency of each and every word. So that 9 is denoting, so big is available 9 times over here, huh? Right? So 1 2 3 4 5 6 7 8 9, huh? So big is available 9 times in this particular data set, right? Fine, all of you.
Yeah, so
Yes, Ashok.
Okay, perfect. So what we have seen, we have gone through with the fourth aspect of our practical, that is adding a partitioner class. And with the help of partitioner class, what we are able to see, we can divide the load or divide the keys among available reducer. Okay, so that is the stuff. Huh? Now the fifth aspect of our practical, that is the combiner class. Huh? Okay, so adding the combiner, and what I have mentioned, combiner is a person who is going to offload reducer. Offload reducer because this is the person who is working on a monolithic way. It is not having the benefit of parallelism. And over here inside the mapper machines, we will be having the bunch of machines or bunch of nodes over here, and these particular nodes are working in parallelism, and our main motto is to finish maximum of the task over here, and less data movement will be done for the reducer, so that we will be having low latency. Our prime target is to minimize the latency so that the job will be executed in less amount of time. So maximum task is done over here inside the mapper machines only, and for that what we are having combiner. Combiner, it is also known as mini mapper, and it is having the same logic which is written in reducer. So just have a look with respect to the logic what we are having inside the combiners. So share folder and just have a look onto the custom combiner class. Partitioner, and over here what we are able to see, custom combiner class. And let me open this. Okay, so let me copy this custom combiner class. Let me copy it from here so that we will not have space related issue. Custom, sorry, partitioner and combiner. So this is the combiner class, and let me try to remove these particular imports. These are, or let me try to keep. It will not be an issue. It is not going to occupy more space. Okay, so this is nothing but combiner class, and let me try to copy reducer class as well. And reducer class. Reducer class. So reducer class, just have a look. reduce. Huh? Okay. Okay. So just have a look and let me try to remove the unwanted stuff for the better clarity. Huh? Okay, that is fine. And from here as well, I'm going to say, or let me try to. So just have a look. Upper one is the combiner class and lower one is the reducer class, what we are having. And what I have mentioned, the combiner class is utilized in order to offload the reducer class. It is going to offload the reducer. So what we have written in reducer class, so reducer class is taking two inputs and providing two outputs. In the same fashion, it is going to take two input. Two input it is going to take from the mapper. So text and writable, that is perfectly fine. Now what we are having over here, text and writable as a and as a output. Text and writable that we are getting from the mapper. Try to focus over here, guys. Text and writable that it is getting from the mapper. Let me try to open the mapper class as well. So what is the output from mapper class? That is text and writable. It is given to this reducer. Sorry, this combiner class. So the combiner class is having input text and writable from this particular chain as well. So mapper is giving uh, output to the combiner. So the mapper output is text and writable. So it is input to the combiner class. So text and writable. Now the output from this is text and writable. Why so? Because the output from the combiner class is given to reducer. Okay, reducer is working onto the output of combiner class. That's why like it is having entry-table, and partitioner is just uh doing like which record, which key is moving to which reducer. It is going to provide the output in this particular way, text and entry-table. So it is just going to forward the records. It is just acting as a filtration mechanism. No processing is happening over here. So that's why like we are having simple stuff inside the partitioner. So this particular combiner combiner's output, that is text and entry-table, is given to the reducer as an input. So text and entry-table is the input, and because of that we are having text and entry-table as output over here. Now what I have mentioned, like it is having the same code, almost same logic, but you just need to follow with respect, or you need to focus onto the input and output. Over here we are having output of combiner, that is text and writable, that is based upon our data, but the reducer class output is text and long writable. So if you are going to say disturb this particular configuration and all, then there will be issue inside the output. Rest of this, like almost the logic will be the same. Just have a look. So over here what we are having set like we are taking text as a key, and then entry table, that is nothing but a value. We are setting a certain context for the output through exception and all, then interrupt, that is perfectly fine. Now what we are doing over here, we are performing certain execution. We are taking we have defined one integer variable, that is count. Okay, and over here what we have done, we have defined an a variable that is of that is count of long type, and then the logic is same over here. What it is doing, it is taking the key, it is going to take the key, and then it is going to calculate, internally it is going to do the calculation, say whatever the key which are available over here in this particular mapper machine, it is going to count, count the values. So what exactly is happening, let me try to show you with practical with notepad,
But
so
Ashok,
mhm.
in case
Let me
of
show,
this
uh-huh.
combiner class, the value of the count may be very high. So is it
You can
not
set,
okay to?
you can set, you can set too long, you can set too long,
Yes, yes, yes,
you
yes,
can set
yes.
too long.
Okay, okay.
Okay, so say this is input, or is, you can say, output from mapper, and what exactly is happening over here, output from mapper, say big, and say data, data 1, data 1, data 1. This is the output from mapper. Mapper has worked in such a way, it has placed one. Now, what this particular logic is doing, it is going to set a particular variable or count that is initially 0 value, and it is going to iterate with respect to, it is going to like have, it is going to iterate with respect to values. So over here the value are these particular, say this is the key and this is, these are the value. So it is going to set a variable over here, we have, it is, we are having a particular variable. Okay, and it is going to iterate from values what we have defined over here, and the count is keep on increasing, and then it is going to write the count, convert the count into iterable and all. That is the Hadoop understandable format, and then it is going to keep the key. Okay, so the output from this particular, say mapper, say big, say 1 2 3 4 5, so big 5 is the output from this particular, say mapper, and data, say 3, this is the out, say we are having, say or you can say node 1, node 1, node 1 has done the calculation, then node 2, okay, node 3, node 3, and node 4, node 4. Okay, so node 4 is, you can think in this particular way, say this is the mapper machine 1, mapper machine 2, mapper 3, mapper 4, you can think in that way as well. Although like we can have multiple mappers in one machine, mappers are equal to the number of blocks, so based upon the mapper 1 calculation, we are having this one. Based upon mapper 2 calculation, say we are having big 1 and say hello data 4. Based upon the node 3 calculation, what we are having big 5 and say data 2. And based upon node 4 calculation or mapper 4 calculation, we are having say big 1. Or you can think like big is not available, only data is available. Or over here, say data is not available, only these particular keys are available, it might be possible like we can have some keys on one machine, another machine can have or cannot have that particular key or value, key. Now previously we were moving a lot of records, so from the mapper 1 machine only, these particular records were shuffled and showed to the reducer side. Now the data is reduced because of the combiner logic. Combiner has done the intermediate calculation or reduced the load of reducer. Now this much keys will be transferred from mappers to reducer side, mappers or combiners are available onto the mapper side only. So small amount of data will be transferred at this moment. And if we are able to reduce the shuffling, that is movement of records from mapper machines to a reducer machine, so at that moment what we can say, we have minimized the latency, because that is the very, you can say, critical operation, and latency is very high at that moment. Clear? With respect to the logic, what exactly this particular combiner is doing, all of you?
Yeah, Suk.
What combiner has done, is it clear?
Yes, yes, it's clear.
I want
Yes,
buying
Ashok, it's
from all of
clear.
you.
Ashok,
Okay,
like in
perfect.
how Ashok, one question is from my side.
Hmm?
How system will it know they are the same logic in both the file and combiner and reducer?
This
How
is written
system will
by
know
us. This is
where it
written
will
by
process?
us. This
Which
is written by us.
no. I can
Hmm?
understand this is written by us. Like in how system can when reducer will process and when combiner will process.
Settings will be done in the main class,
No,
na?
no, 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 no.
First,
Try to
first.
think. Uh, just a minute. Just a minute. Let me explain. So same logic. What reducer is doing? Reducer is going to keep the key and work on value. Same stuff
Mhm.
it has done, but it has done with respect to one mapper only. Okay, it has done with respect to one mapper. Now all these records from node 1, node 2, node 3, node 4, okay,
Mhm.
all these records are moved to reducer. Okay,
Mhm.
reducer,
Mhm.
and it is going to do the same, like big 5 is available over here, big 1 is available over here. Okay, big 1 and big 5 is available from here, will be available from here. And then, okay, now what we are having, it is going to work in this particular way, like it is having the long equal to key, then it is going to count, like it is going to get value dot get at this moment, what it will be, 5. Okay, 5 plus 1 plus 5, so it will be 11. So both are working, right? Both are working, but it is working on one mapper data, and it is working onto the data which it is getting from all the nodes, right? It is not like, say, map miners are resting and reducer is doing nothing. Both are working whatever they are having. This combiner is having data with respect to the mapper machine only, but this reducer is having data with respect to all the nodes from the cluster. Clear? Pankaj and I think Gaurav was there. Huh? Is it clear?
Mm,
Just have a look and ask the doubt. Huh?
I
Just have a look.
think I think Gaurav has dropped.
Okay, okay, not an issue. So did you get?
Actually, Ashok, what I understand that Gaurav wants to ask that how it will be defined that whether combiner will be used or not. I think it was his question.
Actually, like if we have defined the combiner class, and whatever the data
That
it is.
that we have to define in the main class itself. Na? If if we have defined that custom combiner.
Yeah, we need to, yeah, we need
Yes,
to
yes,
define, like we
yes,
have
yes, yes.
defined the partitioner class over here.
Partition. Yes,
Okay,
in the
just have a
in
look.
the main
We have
class.
defined the partitioner class over here. Huh? Okay, so
Yes,
in the
yes.
same fashion, we need to define the combiner class
Com
as well.
Combiner class. Yes, yes.
Okay, So
Okay.
if we have defined that particular combiner class, then the execution will happen and it will try to offload reducer.
Reducer.
So,
Yes.
and the main motto over here is to minimize the movement of record. That's what we are doing over here. Previously,
Yes.
from this particular say node 1, okay, so we were having 8 records. 8 records were moving. Now we are moving 2 records only after
Yes.
implementation of combiner. Perfectly fine.
Yes. Yes.
So Ashok,
Uh,
combiner is working on individual machine, individual mappers, right?
yeah, it is available on mapper machine only. It is available
Mhm.
on mapper machine only.
Okay.
Okay. It is also known as mini mapper. Okay. Let me mention over here. Mini mapper. So, the main motto is to reduce the load of reducer in such a way that less number of records will be moved from mapper machine to reducer machine. Okay. So let me try to implement it with practical. So what we are having a custom combiner class. Okay, I'm going to import that particular class over here, and that is custom combiner class. Okay, so custom combiner class is available over here, and what I just need to do, I just need to add this particular class inside the main class. So let me try to copy this. Set combiner class. Okay, let me active this one as well.
Set. We have to use in main class.
Hmm.
Yes. Yes. And
Just a minute. I think it will work now. So previously, what was happening? The spelling of class was not correct. It was like this only, and I was checking each and everything. So silly mistake. It can happen. Like if we have written thousands lines of code and with a single error, you will not be able to find out. So that is the case. So the thing is that let me try to explain. So this custom combiner class is extending properties of reducer class, because it is acting on the load or on the code or onto the logic which is written inside the reducer. It is taking the inheriting the properties from reducer class. Now inside the main class, what we are just mentioning, we just need to set combiner class and we just need to mention the same name. In the first, you can say once we were getting the error, so it was like this. This particular C was capital. So you just need to keep the same name, like of the file name. So file name is custom combiner class, and you just need to define the same name over here, custom combiner class. So and same you need to define over here now whatever you have used. So custom combiner class, that is perfectly fine. Now each and everything is there, like we are having two reducer, we are having mapper reducer, two reducers are there, partitioner is there, and the custom combiner is also there. And let me try to do the execution of our code, and say fifth execution. Okay, apply, run. Okay, so the execution will start, and we will be able to get the outcome. Okay, and inside this we will be having say fifth execution, and we will be having the outcome. Now you might be worried. So the outcome with respect to fifth execution, that is this one, and the outcome with respect to the fourth execution, that is this one. That is almost same. It is the same outcome what we will be getting. But the main thing is that whatever we were getting inside the fourth execution, that will be having that will be having high latency, because shuffling is more over here. Over here shuffling is more, but once we are having the fifth execution, then the amount of shuffling is less over here, and the movement of the record will take less time, and this will be the performance job with respect to this one. As we are running with one node cluster and very small data, then we are not able to find out the difference between fifth execution and fourth execution. What we are having in this particular project, we are having a certain classes: main, map, reduce, custom partitioner, and combiner. This is like with the id we are going to have the execution of our code, but inside the production environment we are not like running the code in this particular way. I'm showing you the way how inside the production environment, if something is written inside the Java, and if we are working with Hadoop, it might be possible like certain organization, 2 to 3% organizations in the world are working with Hadoop as well. They are writing the code in Java, but our main motto is not to run the code and write the code in Java, or to have the execution of that particular code. Our main motto is to write the code into some different, you can say, languages like SQL queries and all, and the system will internally convert that particular code in Java, and then it will be executed. But if say some organization who have written their code in Java, then how they are going to run it? So what we are going to do at that moment, we need to export these particular jars. So over here, what we are having export option. And export, what we just want to have export. Let me try to export this. Export, and export what? Export Java as a jar file and runnable jar file. Okay. So we are exporting it once again. Okay, so export is done. And let me try to run it once again. It will throw error. Output path exists. That is perfectly fine. Just have a look. User test output 1 already exists. I was expecting this. Let me try to take output in output 2. Okay. So the execution has been started. And this is job tracking URL. You can copy this and you can track your job over here onto this particular path. Let me try to try to check the job from here. Okay, mapper 0, reducer 0. So let me click onto the job that is there. So mapper 0, reducer 2. Let me check the logs, detailed logs, system logs, full logs.
Ashok, why it is showing mapper 0?
Just let me check. Got container 1. Okay. Mapper 0, mapper 100%. At this moment, like execution has been completed successfully. Okay. Now we just need to drill the logs. Okay. So let me go back and I just want to click onto here. Failed while trying to construct log server may not be configured. Let me try to open it once again. Okay, just have a look. So previously, once we have clicked onto this, the the allocation was not done. It was not complete. Right?
Yes, Ashok.
Okay. And
Yes.
over here, average map time. Just have a look. At this moment, we got the counters. Okay. So the job name is word count. That is perfectly fine. User Cloudera, it is running, and the state is succeeded. Okay. Uberized, we will be learning this particular way, parameter Uberized. You just try to keep this particular term in your mind, Uberized. Uberization is a process basically what we will be going to see in Spark. Submitted time, started time, finished time, and lapse time. Lapse time, it is 42 second. Previously it was like I think for 52 second, and job was failed. Job was failed because like export uh, was not done perfectly. And I will show you. I will tell you like what was the issue. Average map time. Just try to focus onto these particular counters. Okay. Map time is 19 seconds. Shuffle time. Shuffle time. Although like we have used combiner, and combiner has done certain processing for us, but still shuffling is there. If you are not using combiner, then this shuffling time will be more, right? This shuffling time will be more at that moment. Merge time and the reduce time. So over here, like what we are having, this is the URL and the logs, then map reduce, and then like with respect to failed, killed, and successful. So two reducer were there, one mapper was there. Okay. So that is providing you the details about the execution, what has happened. And over here as well, at this moment, we will be able to see inside the output too. we will be able to see certain files inside the output too, because the job is executed successfully. Just have a look, like we are having part uh, 5 times 0. This is with respect to the partitioner, sorry, reducer 1. And let me try to show what is the content of this particular file, hadoop fs-cat, and then user cloudera and test and output 2, and then the file name what we are having, part. Okay, just have a look. So this is what, like, what we have seen in Eclipse as well, okay. Once the execution was done with Eclipse, this is the same output, okay. This is the same output what we have seen over there, now we are able to see it with the help of Hadoop. Let me try to repeat it once again. Now, whatever we have covered in our today's session, let me try to recover it once again. So friends, like we have started our day with the addition of partitioner. Partitioner is a person who is going to decide which record is moving to which reducer. And with the help of partitioner class, the simple logic, like if the data, if the key length is greater than 4, then it will be moving to reducer 0, that is the reducer id 1. Or if not, then it is moving to reducer 1. Okay, that is perfectly fine, it was executed successfully. Then we have added combiner, and combiner is doing what? It is going to offload the reducer. And with respect to the combiner, what we are having combiner class, and it is inheriting the properties from the reducer because it is reducing the load of reducer. Perfectly fine, and over here the logic is really very simple. It is going to keep the key and work onto the values, and it is going to iterate with values and provide you the sum. Okay, how, say if we are having certain records in a mapper, then it is going to keep the key and work on to the values, and we will be getting the outcome from the combiner like this, and this particular data will be moved to the reducer. Now over here we are having a kick. The kick is this: it is working uh, on a, it is available, it is providing you the output with single machine, or with respect to the mappers, it is going to provide you the output, say if like mapper 1 is having certain data, so with respect to the mapper 1, it is going to provide the outcome. And the reducer is responsible for taking the input from multiple mappers, and then it is going to provide you the output, so reducer is getting the processed output, okay. It is getting the processed outcome, then it is going to work on that particular outcome, and it is providing you the final output. That is also perfectly fine, we are able to get the outcome with combiner. Now each and everything is fine, but once we are working in production environment, this is not the case that we will be able uh, to write down the code in IDE, and uh, then like we are performing the execution, it might be possible, like you are going to like you are sitting over here in Delhi, and the client is sitting in Mumbai. Okay, are you going to provide the IDs and all? Okay, that is not the case, so what you are going to do at that moment, you are going to export this particular code or project basically, so what we are going to do, we are going to export the project. Okay, export the project in a runnable jar, just click onto the jar and click onto the next. And over here you just need to keep the first option. Okay, you need to select the first option. In the previous execution, once it was uh, not executed, it was throwing error, so we have selected this option, second one, you just need to select the project over here, provide the name of file where you are going to file, and the path where you want to save this particular jar file, and then you just need to click finish. It will trigger certain warnings, but avoid the warnings. You will be able to export the project. Complete project is exported. Now, in order to execute this particular project, we are having a simple command, that is Hadoop jar, then jar file, input path and output path. Okay, input path and output path. Now you just need to keep one more thing in your mind. Over here, you just need to provide the path of Hadoop directories. You just need to provide the path of Hadoop directories. Let me try to do the execution. So say over here, we are having this particular file, Hadoop jar and word count.jar, and now like certain data is placed over here, that is perfectly fine, and I want to execute this particular code with respect to the data which is placed onto the local. Let me try to do the execution. Okay, so just have a look. It will throw file not found. Input path doesn't exist. Input path doesn't exist. Uh, Let me, where we are getting this particular error. Input path doesn't exist. Just have a look over here. Input path does not exist. Let me copy this for you. Copy the entire stuff. Let me copy the entire stuff. Copy and let me paste it over here. Okay. So let me write it. While submitting the Hadoop jar, you need to keep input path and output path from HDFS only. HDFS only. Otherwise, it will show error. Input path does not exist.
Ashok, can you
Mhm.
please explain once again
Yes,
what is
yes, yes.
this
I will
means
explain.
Hadoop path and this
Input path doesn't
HDF?
exist. So, referable example. So, once we are executing this particular jar file, once we are using this particular jar file, then it is expecting the input from the Hadoop path. And which one is the HDFS or Hadoop path? That is user Cloudera. User Cloudera is Hadoop path. And home Cloudera, that is nothing but the local path. That is this one. Let me show you. It's clear. So if I'm mentioning ls, so that is the local or home directory of Linux. Pwd home Cloudera, that is home directory. You can think in this particular way. Okay, say I'm sitting, I'm having this, I'm the user. Okay, and I'm having Hadoop cluster. Hadoop cluster. Okay, I'm having Hadoop cluster, and over here, what I'm having bunch of machines. So once we are performing the execution with Eclipse, so the execution is happening over here, okay, onto the local machine. Okay, the execution is happening onto the local machines once I'm sitting on Eclipse. But Once I'm trying to execute this particular, I'm going to execute with Hadoop. Once I'm trying to execute with jar, then the execution is happening onto the cluster. So cluster at that moment, like what I need to do, I need to provide the Hadoop path. And what is the Hadoop home directory? That is user Cloudera. Okay, user Cloudera, user Cloudera. And over here, what we are having? We are having home Cloudera. Okay, home Cloudera. So previous execution was with respect to this, and Hadoop execution was with respect to this. And you can think in this particular way, like I'm a person, okay, I am going to utilize this Hadoop cluster as we are running with one node cluster only. So both of these particular things are available on single machine. But in the production environment, you are going to access this particular Hadoop cluster. And at that moment, you just need to leverage the HDFS path or Hadoop path. For the execution. So at this moment, it is expecting the data which is stored inside the HDFS. And at this moment, it is expecting the data which is stored inside your local machine. Fine? Is it clear?
Yes, yes, Ashok. Yes.
Now, I just want to take the queries. Anybody having any doubts so far? Anything that you want to ask with respect to what we have covered? Kapil, Gaurav, Vikas, Mukesh, Rohit, Pankaj, anything that is coming in your mind.
No, no queries.
Okay, so challenge was like we were not using the jar. Uh, okay, I was just like I have written over here, but I have not mentioned it over here. So that was the silly mistake which I have done. Okay.
Actually, you have removed, na. So I thought instead of jar, you have used the this path of the jar file. So that's why you haven't used this jar.
No, no, by mistakenly like it was done. By
Okay.
mistakenly it was done.
Okay.
Okay, so that is the case, and another issue which we where we stuck like with respect to the custom combiner name. So what we have done over here, the class spelling was incorrect. In order to perform copy and paste, the class spelling was not like pasted properly, so it was throwing error. And I was trying a lot of things, but finally like we were able to do it. These are the things like uh, which are required less, you can say, concentration from the data engineers or developers perspective. We are not going to write down our code in Java and all. So from the concept perspective, we just need to go through with these topics in order to give you the understanding like what exactly is happening in the back end. Okay, so we will be going to start our new topic from tomorrow onwards. That will be the Hive. We are going to start with Hive, and over there, like once we will be going to execute, you will be able to see, say, some mappers are running, some reducers are running. Okay, and if I'm going to explain, like, say, we are having mappers or we are having reducer. At that moment, you will not be having the understanding. Now you are having enough understanding about the mappers and reducer and the flow, how the execution is uh, being happening inside the big data world. And then at the time, like we can move ahead, you can just go through with these particular topics and try to have the execution at least once, just by copying and pasting these particular code. Don't try to like to drill it further, or like try to go through like what is the meaning of class custom partitioner, extend partitioner, or what is happening, like uh, like why I need to use int writable and all, or what is the meaning of get partition and all, what is the meaning of public. Don't try to go in detail, just try to understand the concepts. Like over here we are just converting the key to string and calculating length. Length is 4, it is going to 0, and it's greater than 4, then it is moving to 1. Just try to run it. If you understand the concept, then that will be that will be fine. Okay. Or like we will I will try to explain it once again, and then you will have the understanding. Just try to understand the concept only. We are not going to write down the code in Java. We just going to understand the concepts. Once the concepts are clear, then we can move ahead with our journey. Okay, so from tomorrow onwards we will be going to start Hive, and that will be going to take MapReduce as a engine, compute engine, and we will be able to see some mappers are running over there once we are going to execute the code. That will be SQL code. So what is happening over here? We are writing code, with writing code in Java, and then it will be say given to MapReduce, and MapReduce is working, and we will be able to get the final output. But what will happen over here once we are going to leverage Hive? We will be writing down the code SQL in SQL, and what we will do, what we will do give it to MapReduce. Okay, okay, and internally, like it is the duty of MapReduce to convert it in Java. Okay, and then we will be able to get the output. Okay, so sorry, Java output. Okay, so we are going to write down the code in SQL, and we will run it onto the MapReduce, and it's the responsibility of MapReduce to convert it internally Java, and then we will be able to get the output. Let me paste this Java over here. Okay, and we will be able to get the outcome in required format. The main thing over here, it's very typical to write down the code in Java, and it is a very lengthy process, and we are not having the visualization as well. Okay, so in order to minimize the code, so for the simple task like for word count and all, like we have written all very lengthy code, and we are having 4 to 5 classes, and in 4 to 5 classes we are performing just word count program, but once we are going to say leverage this SQL or Spark, within just 4 to 5 lines we will be able to perform the same task what we have performed with Java. So that is like, from the developer's perspective, we are it's very easy to learn SQL or Spark. Okay, and then perform our task. It is not like to go through in detail with the Java, which is very, you can say, lengthy, where we are having very lengthy code, and it's very tough for the beginners in order to understand Java and to do the code in Java. So we are not moving with those particular aspects, and from the understanding perspective, like to get the functionality, understanding of functionality, how it is happening in map and reduce. So we have gone through with simple examples, that is not much typical. So that's it, I think, for the today's session. From tomorrow onwards we will be going through with our new topic, and that will be Hive. Okay, and over there we will be trying to perform a lot of operations onto the structured data, and that is like very, very, you can say, important skill from the interview perspective as well. Hive. So from tomorrow onwards, we will discuss on to the Hive. That's it for the today's session. If you are having any confusion, you can ask.